We're doing 6 trig functions non-special. The first thing you need to know to do this problem is the 6 trig functions, which are sine, cosine, tangent, cosecant, secant, and cotangent. For example, if you had a triangle with these sides, the sine would be opposite over hypotenuse, which would be 4 over 5. Cosine would be adjacent over hypotenuse, which is 3 over 5. And tangent would be opposite over adjacent, which is 4 over 3. And then these ones are just the reciprocals. So 5 over 4, 5 over 3, and 3 over 4. The other thing you need to know are the points on a unit circle. So this is 0 and 2 pi, pi over 2, pi, and 3 pi over 2. And this domain restriction will tell you where in between these points you can plot your triangle. So we're given cosine, which is 3 over 5, which means that we need to find the third side in order to solve for these. So I'm going to draw a triangle and draw a right angle and theta, and then cosine is 3 over 5. And this is a special triangle, so we know that this is 4. Now with this information we can write what we know here. So sine is 4 over 5, opposite over hypotenuse. Tangent is 4 over 3, and secant is the opposite of cosine. And we know that cosine is 3 over 5, so we can write 5 over 3. For the squareds, we need to first find cotangent, which is 3 over 4, and then if we square it, we get 9 over 16. Cosecant is the opposite of sine, which is 5 over 4, and then we square it and get 25 over 16. Sine squared, which is right here, we get 16 over 25. Now all we need to find is whether these values are positive or negative. Okay, so cosine is positive with what we're given, and when cosine is positive, it's either here or here. But we have a domain restriction, which is between 3 pi over 2 and 2 pi. So we can cross off the rest of this, and we know that our point is on this triangle. So now sine in this quadrant is negative, tangent in quadrant 4 is negative, and secant, which is the opposite of cosine, we know is positive. All of the squareds, since they're squared, they're always going to be positive.
Now into the second problem. So first, you're going to use negative 9 over 11 for sine and draw your triangle. You'll put your theta in one angle and then your right angle in the other. And then as you're drawing your triangle, you can ignore this negative. And so you'll put 9 over here and 11 over here. And so now you're going to use Pythagorean's theorem to find this side right here. So I'm going to square 11, and that'll be 121. And then I'll subtract this side, and that'll be 81. That'll all be 40. And then to find this side, you're going to have to square root it, but using a factor tree to simplify it. So that'll be 4 and 10. Ooh. Then simplify 4, which would be 2 and 2. And then to simplify 10, it would be 2 and 5. So since you have 2 2's, that'll be outside the square root, which would be 2, and then multiply these two together, which is root 10. So 2 root 10. So now we write what we know. So we know cosine is 2 root 10 over 11. We know tangent, which is 9 over 2 root 10. And then we can do secant, which is the reciprocal of your cosine, which would be 11 over 2 root 10. Okay, for cosine squared, you take cosine and you square it. And in order to do this, you square 2, which will be 4. And then when you square a square root, it'll get rid of that square root. So it'd be 4 times 10, which is 40, over the 11 squared, which is 121. Then this is sine squared, but it's the reciprocal of that. So you take your sine, 9 over 11, and you square that, which is 81. It'd be 81 over 121, and since it's the reciprocal, you do 121 over 81. And then to find cotangent squared, you take the tangent and you square it, which would be 81 over 40. And then you use the reciprocal, which is 40 over 81. So we know that negative sign is in the third quadrant and the fourth quadrant. And using the domain restriction, we find that we can cross out all these other quadrants, and it is only in the fourth quadrant. So then we go over here and find that cosine is positive, tangent is negative since it's in the fourth quadrant, secant is positive since it's the reciprocal of cosine, and then every squared is positive since it's a squared.
Okay, on to the third problem. So we have cosine is negative 2/7, and the first thing we need to do is find the third side. I draw my triangle, and then do the same thing, theta in the right angle. And now cosine is 2 over 7. To find the third side, use Pythagorean theorem, which is 2 squared plus x squared, which is the side, equals 7 squared. And now you can subtract 4 from 49, then take the square root of that, which is 45, and then simplify it. So you get 5 and 9, and then 3 and 3. There's 2 3's, so you take those out of the square root, and it's 3 root 5. These two are equivalent. Now we write what we know from this. We know that sine is 3 root 5 over 7. Cotangent is the opposite of tangent, which is 3 root 5 over 2. And now we take the reciprocal of that, which is 2 over 3 root 5. And then cosecant is the opposite of sine, so we can do 7 over 3 root 5. Tangent squared is this value squared. And 3 root 5, instead of squaring this, it's easier to square the square root of 45. So we know that that is 45 over 4. Secant squared is the opposite of cosine, and we know that cosine is 2/7, and so we can square 7 halves. And that gives you 49 over 4. Sine squared is this value squared, which gives us 45 over 49. Now to find out if these values are positive or negative, you plot where cosine is negative, which is here and here. Then you look at your domain restriction, and you know that it's between pi over 2 and 3 pi over 2, so we can ignore this half of the unit circle. So looking at this, we know that sine in quadrants 2 and 3 can be either positive or negative, and so we have to write a plus or minus in front of it. Cotangent in this quadrant is negative, and in this quadrant it's positive, so we write plus or minus in front of cotangent as well. Cosecant is the opposite of sine, and for the reciprocals it's always the same sign, so we write plus or minus again. And then all of the squareds we leave alone because squareds are always positive.
As a review, we'll just show you each problem, and you can look it over and review the answers. So here's one. and 2. And then problems 3 and 4.